All right, so today I am talking about how to write the equations of parallel and perpendicular lines. So when I'm writing equations, by the way, always keep in mind that I want something equals something, right? So that's what we're going to talk about today. Parallel lines, if we are observing parallel lines, they are called parallel because they don't intersect ever. So they don't cross ever. That's what intersecting means. But specifically, there's something else that happens with parallel lines. Now, if I'm looking at the slope of line 1 right here, I'm going to pick 2 points. I'm just going to do rise over run because that's what slope is. So slope M is rise over run. So I know I'm going to start with the left side and I'm going to go up 2 to the side 3. 1, 2, 3. So 2 over 3. And if I'm looking at line 2, I'm going to do the exact same thing. Pick 2 points, perfect points. You're nice. And I'm going to go up 2 to the side 3. So up 2, run 3. And now if I'm looking at my slopes, I can notice that they're the same. They are the same. So that means that parallel lines are not just parallel because they don't cross. Specifically, their slopes are the same. And if they're the same, then they're never going to cross. So that's why I call them parallel. They have the same slope. Now, if I'm looking at perpendicular lines, yes, perpendicular lines intersect, they cross, but they cross specifically at a 90-degree angle. So when I'm looking at these two lines, if I could imagine an angle, there would be a right angle, 90-degree angle right there. And I've got to do the exact same thing, so I'm going to notice something when I look at the slopes. On line 1, start here, I could go here, up 2, to the side, 1, 2, 3, so 2 over 3. But when I compare it to the slope of line 2, still starting from the left, so I'm going to go 1, 2, 3. And because I'm going down, this time it's down -2, or -3. 1, 2, 3. So down -3 over 1, 2. So I can see here that not only, they're not the same, right? They're very much the opposite. They're the opposite in the sense that this one was positive, now it's negative. So they're opposite signs. Did I spell that right? Opposite. Opposite signs. And they are also, I notice here I have 2 over 3. On the other one is 3 over 2. So they flipped. So opposite signs and flipped. And when this happens, those lines are then called perpendicular. So when I have opposite signs and I flip my slope, I get perpendicular. When they are the same and parallel, they're the same slope, it's parallel. Okay. All right, so now I'm going to look at the examples that I have right here. Y equals -5x plus 7. If I'm looking here, first of all, to know the slopes, the parallel slope and the perpendicular slope, I've got to know what is the original slope. This is in y equals mx plus b. So my slope is -5. So if I'm looking for the parallel slope, that's just going to be the same, -5. But if I'm looking for the perpendicular slope, that's going to be opposite. Opposite of negative is positive, and flipped. Now I see that that is 5. That's the same thing as saying 5 over 1. So 1 over 5 when I flip it. Here is my slopes. Parallel, -5. Perpendicular, positive 1 over 5. Before I try the middle one, I'm actually going to skip over to this third one. If I recognize this form, we've been talking about it a lot, it's my point slope form, where I have y minus y1 equals m x minus x1. So when I'm just looking for a slope, here is my slope, right? To the left of the parentheses x. By the way, if I'm looking for the original point that was used here, the point slope, it would be -7. That's how I get it to be positive, because my formula usually starts with minus. And this one's just, here's the y, here's the minus. Okay, so the point was 6. But anyways, just this extra little review. My actual parallel slope, if it's the same, it's going to be -1/4. And for my perpendicular slope, I'm looking for opposite signs and flipped. So opposite's going to be plus. If I flip this, it's 4/1. And 4/1 is really the same thing as 4. Positive 4, 4, same thing. So there's my slopes. And now let's look at the middle one. I have 9x minus 2y is equal to 10. This is another form, so we've had all three types of forms. Here's slope-intercept, point slope. Now this is standard. On standard, I cannot say that this is slope. I know it's next to my x, but this on standard is ax, not mx. So for me to actually be able to tell what the slope is, I'm going to have to solve for y. So here's solving for y. Move the x over by adding or subtracting. So minus x, 9x. 9 minus 9, 9x minus 9x, 0. So that gives me -2y equal to, and I'm going to flip the order of these two guys because I want mx plus b, right? I want my x to come first. So -9x. I still have the 10. When I look at it here, it's positive 10. So this is plus 10. I want to make sure I separate these two terms with a sign. Okay? Now I'm just going to do one more thing. I still don't have y by itself. So if I divide, move and divide by -2, I could get that to be by itself. Keep in mind that when you divide, you're going to divide everything. Okay, so -2 over -2, same thing as 1. 1y, same thing as saying y equals -2 over, or -9 over -2. When I have negative over a negative, that's going to turn positive. Positive 9 over 2x. And then plus divided by a negative, that's going to be a negative 10 over 2, which is 5. Okay? Now I'm going to look for my parallel slope. I know parallel slopes are the same. So now that I have it in my slope-intercept, here's my slope. So my parallel slope, just the same. My perpendicular slope, instead, is going to be opposite and flipped. Opposite, flipped. So opposite of that is going to be negative. It's right here. This is positive. So negative, flipped, 2 over 9. Okay. Now we can see the relationship here, right? Parallel, same slope. So if I start with negative, this is still negative. If I start with if I start with negative and I want perpendicular, now it's positive. So let's talk about that for a second, because that is really important to know. When we think about our types of slope, we have a little cheat sheet called Slope Mountain that tells us about slope, right? If I'm going from left to right, I'm going up. This is positive slope. If from left to right, I go down, this is negative slope. If from left to right, I just stay still, and horizontal the whole time. It's called zero slope. And the equation for that would be y equals a number. And if I'm just on the same line the entire time, I don't even go left and right. I just go up and down, up and down. That's my vertical line. It's got an undefined slope. And the equation for that is x equals a number. So x equals 3, x equals 5. That's all going to give me this line. Okay, so we just saw, right, perpendicular means if I start with positive, it's going to be negative. If I start with negative, it's going to be positive. So for perpendicular, positive slope turns negative. Negative slope turns positive. They're opposites. So then what's the opposite of a zero slope? Well, in terms of slope, if I start with zero slope, the opposite is actually going to be undefined. This happens because the opposite of a horizontal line is a vertical line, right? Vertical. And vertical lines have an undefined slope. So then if I'm starting with a vertical line this time that has undefined slope, the opposite is going to be horizontal line. So if I start with undefined slope, perpendicular slope is 0 because horizontal lines have 0 slope. So just keep that in mind. It's really important to know. Perpendicular slope of 0 is undefined. Undefined, opposite or perpendicular is 0 slope. Okay. Let's talk about the back for a second. Writing equations given a point in a parallel or perpendicular line. Okay, so this is going to be a process, 5-step process, where we're given a lot of information and we got to be able to tell what does this all mean, right? So let's just read first. Write an equation in slope-intercept form. Slope-intercept form. I know slope-intercept form is y equals mx plus b. So this is my end goal, to have it here. Slope-intercept form of the line that passes through, that's a point, 12 comma negative 4, and it's perpendicular, opposite slopes, and flipped. To the line, y equals negative 2 over 3x plus 5. Okay, we got a lot of information. We're going to digest this and just take it step by step. First of all, determine the slope of the given line. So if I'm looking at all this information, they gave me a line, right? The line y equals negative 2 over 3x plus 5. So what's the slope of that? Well, I know it's mx plus b, m next to x. So my slope, given slope, is negative 2 over 3. Okay. Now I've got to determine x and y from the given point. My given point, pretty clear to see, is 12 comma negative 4. So now I've got to determine x and y. Well, I know x comma y. That's the order of points always. All right, step 3, that was pretty easy. Determine the slope of the new line. Use the same slope if the equation is parallel, if the equation of a parallel line was given. Did they give us parallel? Nope. Use the opposite reciprocal of the slope if the equation of a perpendicular line was given. Yep, there it is, perpendicular. Now, opposite reciprocal is what we've been calling flipped. So that just means the number's flipped. Okay, and they do ask us right here for a perpendicular line. So we had our given slope was negative 2 over 3. But now, because this is asking us for perpendicular, the perpendicular slope is going to be opposite plus flipped, reciprocal, 3 over 2. So here's the slope that I've got to use. Positive 3 over 2. Okay. Now I've got to actually write the equation in slope-intercept form, using the given point and the new slope right here. Well, the thing is, for slope-intercept, I need a slope and I need an intercept, specifically the y-intercept. But y-intercept always looks like 0, comma, something. And the given point is not 0, comma, something. So I can't just put this into y equals mx plus b form. I'm actually going to start with my point slope form. I just have a random point. If I just have a random point, I'm going to put it into point slope. Here is point slope form. Y minus y1 is equal to mx minus x1. M is my new slope right here. So I'm going to use 3 over 2. X minus. Now that next x1 right here from the formula is really coming from right here. The given point, x1. So minus 12. And y minus, same thing with y1. That's just coming from y1 right here, from a given point. So minus negative 4. All of that is equal right here. All right, so we used the slope, we used the point. Now I want to simplify this whole mess and get it to y equals, right? I want it in slope-intercept form, so y equals mx plus b. All right. If I see minus parentheses negative, that just means minus is going to multiply to that. And I know that when I have negative times the negative, that's going to make it a positive. This is y plus 4. Now 3 over 2 and parentheses x minus 12 parentheses. If I'm looking at y equals mx plus b, that doesn't have a parentheses. So I'm going to take that away by distributing the outside to the inside. And distributing means to multiply. So 3 over 2 times x is 3 over 2x. 3 over 2 times negative 12 is going to be negative 18, I believe. Yeah, negative 18. And I can always double check that on Desmos. There's no way I should get that wrong because this is going to be on my Desmos. I think I have it somewhere here. Yeah. So, what is that? 3 over 2 times multiply, negative 12, negative 18. Okay, perfect. Now it almost looks like y equals mx plus b. But I've still got this plus 4 here that I want to take care of. So the way that I'm going to move that plus 4 is by doing the opposite. Minus 4 on one side, the inverse. That means minus 4 on the other side. And I don't want to mix this minus 4 with this 3 over 2x because this thing does not have an x. You can't just mix it with x. I'm just going to put it with the other constant, the other number right here. Okay, so 4 minus 4, that just became 0, so that's gone. I drop my y, and I have y equals 3 over 2x. Don't make a silly mistake and get this wrong. Negative 18 minus 4. I'm double checking that on Desmos. Okay, negative 22. Now, Remember, our end goal was to get this y equals mx plus b. I've gotten it y equals mx plus b. Okay, so we're going to do the same for a couple more examples. And I'm going to skip over example 1 and 2. This perpendicular, slope-intercept form, they gave us a point. It's exactly what we just discussed. I'm also going to skip over example 1. The only difference is it's parallel, but it's exactly what we just did. What I do want to talk about, well, I want to mention this right here be the same as 1 over 2. So if I'm looking for slope, I'm going to start with my slope being 1 over 2. Just a quick note with decimals. All right, so I do want to look at example 3, because example 3, I'm being asked what is the equation in slope-intercept form? So y equals mx plus b. It's my end goal. Of the line that crosses the x-axis at 12 and is perpendicular to the line represented by y equals negative 4 over 9, x plus 2. Okay, it's probably good info. Let's go through the steps again just to show you one more time. Determine the slope of the given line. The given line is the y equals negative 4 over 9, x plus 2. So my given slope is negative 4 over 9. Okay. Now I'm going to look for x and y from the given point. But I don't see a point here. So don't panic. I know a line is crossing at 12. X 12. Here's x, crossing it at 12. So that means that there's a point there on that line where my x is 12, and anytime I'm on the x-axis, my y is just going to be 0. So 12, 0. So there's my given point. 12, 0. Actually have to use a little bit of logic here. All right, we've got a given point. We've got a given m. But am I using that actual given m? Well, it just depends. Is it parallel or perpendicular? In this case, parallel, perpendicular. It's perpendicular, which means I'm going to use the opposite and inverse. Opposite plus, not inverse, reciprocal. So flip 9 over 4. Okay. Here's the slope that I'm going to use. Here's the point. Let's put it into point slope. Y minus, gotta see, what is it? X comma y. So y minus 0 is equal to, here's my slope, 9 over 4. Now x minus, there's the x, 12. Y minus 0, just like 10 minus 0 is 10, and 5 minus 0 is 5, y minus 0 is y. And if I want to get into slope-intercept form, because remember, that's the end goal, if I get it into slope-intercept form, I don't have parentheses there, so I don't want parentheses here. 9 over 4 times x is just 9 over 4 x. And 9 over 4 times negative 12. That one I don't know. It's just Desmos. Easy. Let's see. What is it again? 9 over 4 times negative 12. Negative 27. Now it's in slope-intercept form. I can see I am perpendicular to what we started with. Opposite and flipped. There we go. So if I put this line into Desmos, and if I put my original one, guess what's going to happen? Let's see. The original was y equals negative 4 over 9x plus 2. If I flip, if I have a perpendicular line to that, let's see if this looks perpendicular. 9 over 4x minus 27. Okay. Yeah, that looks like the perpendicular picture we had over here. Oh, look, they almost match up in the middle of my screen. Very nice. So that looks perpendicular. We achieved our goal. Now we're going to look at one more example that we haven't done yet, which is, what is the equation in standard form? Oof. Standard form. ax plus by equals c. So what is the equation in standard form of the line that passes through the point? They do give me a point, 3, negative 2, and is parallel to the line represented by 3x minus y equals 2. Okay, so we've got several things to do. First of all, I need slope, right? I need my given slope. But I don't know my given slope because if I look here, ax 3x minus y, this is in standard form right here. A is not slope. A is just a number, a coefficient. I need m. Well, y equals mx plus b has m. So I'm going to solve for y so that I can get this into y equals mx plus b, and then I know slope. So let's see. 3x minus y equals 2. Solve for y. Negative 3x on one side minus 3x. That's just 0. And then I get negative y equals, I'm going to bring the x first, negative 3x plus 2. I still don't have actual y. I have negative y. I want y by itself. So I can still divide. Move and divide, right? That's our 2 steps. Move, divide. If I divide this by negative 1, negative 1y, that's really negative 1y. So negative 1 over negative 1 is 1. But I've got to divide everything else by negative 1. Okay. So negative divided by negative makes it a positive. 3 over 1 is 3. It's just x. And then positive divided by a negative is going to be negative. And 2 over 1 is 2. Okay. Now, we can look back. We got m now, right? My given m is 3. And if I want it to be parallel, same slope. So my parallel slope here is 3. So that's what we're going to use. All right, now I'm going to start with, since I just have a point, I've got to start with point slope. Y minus negative 2. I'll do it. Y minus negative 2. Here's my y, and x is equal to 3. Slope x minus 3. Right here. Negative times a negative gives me y plus 2 equals 3. And remember, my end goal, standard form right here, does not have parentheses, so let's take care of it right now. 3 times x, 3x, 3 times negative 3, negative 9. Okay. Let's see, standard form, gotta keep the end goal in mind. X and y are on the same side when I look at standard form. The c is just number by itself. So I want all the numbers by themselves to go to that side. I want all the x's and y's to go to the left. Let's do that. Let's take it one at a time. This plus 2, I want to take it to the left, or take it to the right. So I'm going to do minus 2, minus 2. Plus 2 minus 2 is 0. So it just leaves me with y. Still have 3x over there. Negative 9 minus 2, negative 11. Double check it on decimals. Now I want the x to also go to the left. I'm going to switch it. The way I move across an equal, anytime I just want to move, I have to do either add or subtract. So here I'm going to do minus 3x, minus 3x. All right. Negative 3x, and then this is a plus y, because that's positive. Still want to keep these separate. So plus y is equal to 3x minus 3x, big ol' 0, that goes away. Left with negative 11. There's something else though. I know, it's like, oh, we did so much work. This a right here cannot be negative. Has to be positive. So if I want that to be positive, I'm going to do one more thing, and that's it, I swear. One more thing. I'm going to multiply this by negative 1. So negative 1 times negative 3, positive 3x. Negative 1 times y gives me negative y. And negative 1 times negative 11, positive 11. Okay. The equation in standard form, check. We got standard form right here, check. And we went through all that trouble to find the same slope. And we used our point. We used our point to get all the way down here. So there is my standard form equation. You know, we went all over the place trying to find all sorts of information. That's just what you're going to have to do. Okay? Math is work, but it's doable. Okay? All right, so hopefully you don't have any other questions. If you do, come see me in tutoring, of course. Keep in mind your perpendicular slopes for the assignment, especially on question number 3. And have a good one.